Good morning, Rohans, Anushka. एक महत्त्वाचं सांगायचं होतं तुम्हाला. आपला एक ग्रुप बनवूया आता इलेक्ट्रॉनिक्स 11 इलेक्ट्रॉनिक्स. कोण बनवेल? अनुष्का, रोहन, स्पंदन, मयांक, एनीवन? तुमचा जो हा कॉमन ग्रुप आहे ना 11चा, त्याच्यावर लिंक पाठवा. अँड फॉर इलेक्ट्रॉनिक स्टुडंट जॉईन दिस लिंक असं करा. अनुष्का करू शकते? करशील आज? मग मी त्या ग्रुपवर तुम्हाला नोट्स आणि डिटेल्स त्या ग्रुपवर पाठवत जाईल. ओके मयांक, समजलं अनुष्का? आज करशील ते लिंक पाठवेल तिकडे. तुम्हाला ज्या नोट्स सेमीकंडक्टरच्या पण नोट्स मला द्यायच्या आहेत, त्या नोट्स आणि मग डिवायडेड सिलेबस पीडीएफ सगळं मी त्या इंडिव्हिज्युअल ग्रुपवर शेअर करेन. सो जॉईन दॅट इंडिव्हिज्युअल ग्रुप. Yes, Anushka. You have to create group and send link on our common group of 11. 11 JE का join है ना तुम्ही campus और JE दोनों ग्रुप वर ते टाकशील. Okay, thank you. Okay, then Mayank, you create. Is it possible for you, Mayank? I can't understand that question proof. Your individual create that which mobile number you are using. On that create a group and send that link on our. ती लिंक तुम्हाला आपल्या लेक्चरची कुठल्या ग्रुपवर मिळते त्या ग्रुपवर ती लिंक शेअर करा and join this group for electronic students only. असं टाका. Join the electronic group. ओके, म्हणजे आपला वेगळा ग्रुप झाला की मला नोट्स पीडीएफ देणं सोपं होईल. तिकडे फार डॉक्युमेंट्स कशाला वाढवायचे? कॉमन ग्रुपवर आपले स्टुडंट लिमिटेड आहेत म्हणून मी त्या ग्रुपवर काही टाकायला अवॉइड करते. ओके ओके, ठीक आहे. Now we will continue yesterday's topic. That in our last lecture we studied about current division. आता खरं इलेक्ट्रॉनिक्स सुरू झालं. इंटरेस्टिंग. करंट डिव्हिजन समजलं तुम्हाला. whenever resistances are in series, current through them is same but potential drop across them is different. So suppose I is the current through R1 and R2, where R1 and R2 are in series. At that time I is the current through R1 and I is the current through R2. But V1 is potential drop across R1 and V2 is potential drop across R2. So what is the formula for V1 and V2 according to current division? V1 is equal to R1 upon R1 plus R2 into V. So before going to current division, we try to simplify one numerical that in yesterday's lecture, in the starting, we studied about internal resistance. So I draw that diagram like this. Here internal resistance and here another resistance, that is a load resistance, and here output that equal to terminal voltage equal to V0, or it is also termed as VRL, voltage across RL. And here that is Vs or VNL, Vs equal to VNL, no load voltage. It is termed as a source voltage or no load voltage. And here your internal resistance Ri, sometimes termed as a small r. And here your load resistance RL. Now these two resistances are in series. How you understand whether the resistances are in series or not? Here, suppose these are two resistances. Only between these two terminals there is a battery. Just high resistance, there are flexible wire. This resistance is here and this resistance is here. But only one end of these two resistances is connected. Between another end there is a battery. That's why these two resistances are in series. Okay, these two resistances are in series. And for parallel resistances, both ends of these two resistances R1 and R2, this end is also connected together, this another end is also connected together. At that time we say that R1 and R2 is parallel. So here one end of R1, this end and R2 is connected, but between these two ends there is a battery. Therefore these two resistances are in series, and here one after other. Therefore, these are in parallel. So, you must understand about series and parallel. So, because flexible wire, they are connected in different manner. Flexible wire असणारे wire अशी जरी केली तरी ते series अशी दोन resistance series मध्ये ते अशी केली तरी series मध्येच राहणार. तर कसं लक्षात ठेवायला सांगितलं मी तुम्हाला one end connected असणार आणि दुसऱ्या एंड मध्ये दुसरा कंपोनेंट असेल तर ते सिरीज मध्येच असणार आहे आणि दोन्ही एंड ज्या वेळी कनेक्ट केलेले असतात at that time these two resistances are in parallel. Do you understand? Okay. So here these two resistances are in series. Now you understand potential division. So potential is applied. Source voltage is termed as Vs, sometimes no load voltage. Source voltage is termed as no load voltage, VNL. VNL means what? No load voltage. Actually, suppose 3 volt battery is there. So 3 volt is termed as a Vs. Sometimes that 3 volt is termed as a no load voltage. And output voltage sometimes termed as a terminal voltage. Sometimes that output voltage is denoted by V0. Sometimes that your output voltage is termed as a VRL, voltage across load resistance RL, and here your internal resistance. So how you calculate that Vs is equal to VRR plus VRL. Now here your R1 means your Ri, your R2 means your RL, and your total V voltage is your Vs. So V is equal to V1 plus V2. Like that, and you know the formula for VRR, voltage across internal resistance is given by Ri upon Ri plus RL into Vs. Do you understand? This same potential division formula is implemented here. That voltage across this internal resistance is given by Ri upon Ri plus RL into Vs. And what is VRL? Voltage across load resistance RL is given by RL upon RR plus RL into Vs. Do you understand? Okay. In this way, now we try to simplify the numericals on internal resistance of the cell. Any question about this two? Okay. Do you understand how we implement our formula of potential division? Here two resistances are in series. हे तुम्ही असं करून घेतलं की ते सिरीज मध्ये दिसणार. And here battery of potential Vs in place of Vs in place of R1 there is Ri in place of R2 there is RL. So our formula is Vs is equal to V1 plus V2 that is VR1 plus VRL. So here V1 formula for V1 is R1 upon R1 plus R2 into V. What is our R1? Ri. What is our R2? RL. What is our V? Vs. So voltage across first resistance is Ri upon Ri plus RL into Vs. आपण ह्या ज्याही values असणार by using this formula we are able to calculate the value of Ri also, value of RL also, the value of output voltage also. Okay. So write down one numerical. एक्सरसाइज घेऊया. सॉल्ट पण दोन न्यूमेरिकल तुमच्या टेक्स्टबुक मध्ये दिलेले आहे. सॉल्ट तुम्ही बघून घ्याल. एक्सरसाइज आपण सॉल्व करूया. Okay, so write down one numerical from our textbook. Write down. Page number 36, exercise 1, chapter 1, exercise 1. This numerical write properly in your classwork notebook. Notes मध्ये numerical नसणार आहे. क्लास मध्ये सगळे numerical exercise चे unsolved सगळे numerical मी सॉल्व करून घेते नेहमी. Unsolved जे आहेत ते आणि solved फक्त आपण डिस्कस करतो. तर त्याच्यामुळे हे नंतर नोट्स मध्ये मिळणार नाहीये. याचं सोल्युशन तुम्हाला परत कुठेही मिळणार नाहीये. सो राईट डाऊन इन युअर क्लास वर्क नोटबुक. आणि एकदा का आपला ग्रुप झाला की तुमच्या क्लास वर्कच्या नोटबुकच्या पीडीएफ मला पाहिजे असेल चॅप्टर झाले की. अंडरस्टँड? सो राईट डाऊन पेज नंबर 36 चॅप्टर 1. Write down that question 1. A DC source has, write down first. A DC source has no load voltage of 3 volt. A DC source has no load voltage of 3 volt and internal resistance of 2 ohm. And internal resistance of 2 ohm. Full stop. It is connected to the load resistance RL. It is connected to the load resistance RL that can vary from 4 ohm to 10 ohm. That can vary from 4 ohm to 10 ohm. Okay, full stop. Find the variation in terminal voltage of the source. Find the variation in the terminal voltage of the source. Full stop. Again I repeat whole numerical. A DC source has no load voltage of 3 volt. And internal resistance of 2 ohm. It is connected to the load resistance RL that can vary from 4 ohm to 10 ohm. Full stop. Find the variation in the terminal voltage of the source. Now, when we start simplifying any numerical, first we try to write down given data. What is given in first line? Though you doesn't understand numerical, then read one line and what is given and what they ask to calculate. You write down, then you easily get the formula between that quantities. A DC source has no load voltage. No load voltage means Vs is given. Node given. Given for first. Page number 36. Exercise first. Question first. त्याचा आन्सर आपण आता सॉल्व करतोय. Given DC load voltage means Vs is given, that is also termed as VNL. No load voltage is equal to 3 volt. Vs ची व्हॅल्यू दिली आहे 3 volt. And internal resistance of 2 ohm. Ri is equal to 2 ohm. This is, we come to know from first line that source voltage or no load voltage is 3 volt and internal resistance is of 2 ohm. It is connected to load resistance RL that can vary from 4 to 10 ohm. So we write 2 RL. RL च्या दोन व्हॅल्यू दिल्या. RL1 is equal to 4 ohm and RL2 is equal to 10 ohm. And what they asked to calculate? Find the variation in terminal voltage. Terminal voltage VT1, which is output voltage, is equal to what? And VT2 is equal to what? Variation in terminal voltage. Because when you consider this RL1, then our terminal voltage is VT1. And when you consider that load resistance value is this one, at that time we get output voltage or terminal voltage is this one. This is given data that we insert in this diagram. According to that, we may draw the diagram like this. Here 3 volt is given, here 2 ohm is given, the variable resistance is denoted like this. This RL value varies from 2 ohm, 4 ohm to 10 ohm. Means our minimum point the value is 4 ohm and maximum point the value is 10 ohm. And what they asked to calculate VT1. We are having formula for terminal voltage. Terminal voltage VT1 is equal to, how you calculate? VT1 means voltage across RL. That is our terminal voltage. So according to potential division, how you calculate the potential across load resistance RL? VT1 is equal to RL upon RI plus RL into Vs. So RL1 upon Ri plus RL1 multiplied by Vs. In this way, we will calculate the terminal voltage. Terminal voltage. Why 1 is in? Suppose only load resistance value is directly given. Load resistance is this one. Find out the terminal voltage. Then that RL2 is not there. But they with same numerical we have to calculate 2 times. समजतंय का सगळ्यांना? लोड रेजिस्टन्सच्या व्हॅल्यू दोन वेगवेगळ्या दिलेल्या आहेत. लोड रेजिस्टन्सची व्हॅल्यू जेव्हा 4 ओहम असेल त्यावेळी काय आन्सर येईल ते पण काढायचंय आणि लोड रेजिस्टन्सची व्हॅल्यू 10 ओहम असेल त्यावेळी तुमचं टर्मिनल व्होल्टेज काय असेल ते पण काढायचंय. म्हणजे एकच पद्धतीने दोनदा सॉल्व करायचंय. पहिल्या ह्याच्यामध्ये लोड रेजिस्टन्सची व्हॅल्यू 4 ओहम टाकायची, दुसऱ्या ह्याच्यामध्ये लोड रेजिस्टन्सची व्हॅल्यू 10 ओहम. And procedure and formula similar असते. So VT1 is equal to हा कुठून आला formula? Everyone understand this? According to potential division, the potential across this V2 you try to calculate. That RL upon Ri plus RL into Vs. This is our standard formula. So we insert the values. That VT1 is equal to RL1 is 4. Upon Ri by 2 plus 4 multiply Vs is 3. Therefore VT1 equal to 12 upon 6. Therefore VT1 is equal to 2 volt. Okay. Write down simultaneously with me. Terminal voltage is given by RL1 upon Ri plus RL1 into Vs. So insert the value in given. We already insert all these values. कुठलाही न्यूमेरिकल सॉल्व करताना प्रत्येक लाईन केअरफुली रीड करायची आणि त्यात काय दिलेलं आहे that you have to write down like in given data what they asked to calculate, what is the relation between this and this. You come to know that you know the formula for terminal voltage by using potential division. So the formula is this one, potential across load resistance. VT1 means potential across load resistance. So RL1 upon RL1 plus RI is equal R2 upon R1 plus R2 into V. Okay. Now, how you calculate VT2? VT2 is equal to RI2 upon RI plus RI2 multiplied by VS. So terminal voltage 2, for that you have to take the value of load resistance now 10 ohm. 10 upon 2 plus 10 multiplied by 3 is equal to 30 upon 12. Therefore, what they ask to calculate? Variation in terminal voltage. You get terminal voltage. Whenever load resistance is 4 ohm, at that time you get terminal voltage is 2 volt. And whenever load resistance is 10 ohm, you get output terminal voltage is 2.5 volt. The terminal voltage varies from 2 to 2.5 volt. What is your answer? Answer, terminal voltage varies from 2 to 2.5 volt. Okay? Any question about this? Yes, ma'am, right. Now we able to calculate percentage variation also. Write down all these steps. Write fast. How you calculate percentage variation? Therefore, percentage variation in terminal voltage is equal to now VT2 minus VT1. VT2 minus VT1 upon VT2. Okay, 2.5 minus 2 upon 2.5 equal to 0.5 upon 2.5 equal to 5 upon 25. Zero point multiply by 100, you know. 20%. Okay, means in this way, 20% variation due to the change in whenever load resistance varies from 4 to 10, 20% variation in the output terminal voltage. Okay. Any question about this? Everyone understand this numerical? Textbook मध्ये आधी हे कॅल्क्युलेट टर्मिनल व्होल्टेज हे न्यूमेरिकल घेतले आहे आणि पोटेन्शियल डिव्हिजन नाही शिकवले. हा पण म्हणून आधी आपण पोटेन्शियल डिव्हिजन शिकलो आणि मग हे न्यूमेरिकल घेतलं. Therefore it is easy for you to understand this formula. तो कुठनं आला हे पण कळायला हवं की नाही आपल्याला. Okay. Now we start current division. Any question about potential division? Everyone understand this? Next one, current division. Now two resistances are R1 and R2 are in parallel. Two resistances R1 and R2 are in parallel. Both ends of these resistances are connected together. So we say that R1 and R2 are in parallel combination, and V is the potential of the battery which is connected across this parallel combination. Now here I is the current due to this battery potential. Now here at this node, as I discussed in our last lecture, that the Kirchhoff's current law, according to that, incoming current is I and two branches are outgoing. So here I1 is current through R1 and I2 is current through R2. Again at that point, incoming currents are these two and outgoing is these two. This one, therefore, here what we write? I is equal to I1 plus I2 and V is equal to I into overall resistance. V is equal to IR. What is the resistance? Total. RP is the total resistance. And whenever you know that whenever two resistances are in parallel, current through them is different, but potential drop across them is same. Means V is the potential drop across R1, V is potential drop across R2, and here connected potential drop is V. Means overall potential drop is same because these two are in parallel, but current through them is different. Okay, so we try to find out. We know that I is equal to I1 plus I2. For now, by current division formula, we try to find out the value of individual I1 and value of I2. Of course, this I1 and I2, both this current depends upon the value of R1 and R2. So the formula for I1 is R1 upon, R2 upon R1 plus R2 into R. According to current division, you may say directly that the I1 is equal to R2 upon R1 plus R2 into R. पोटेन्शियल डिव्हिजन मध्ये तो ज्याच्यातनं पोटेन्शियल काढायचं होतं ज्याच्या अक्रॉस तोच न्यूमरेटरला होता. इथे यातून जाणारा करंट काढायचा आहे तर पॅरलल कॉम्बिनेशन मला रेझिस्टन्स न्यूमरेटरला आहे. सो R1 is equal to R2 upon R1 plus R2 into R, and similarly I2 is equal to what? R1 upon R1 plus R2 into R. How it comes, that also we verify, because we write for individual V is equal to I into RP. What is the value of parallel combination of this RP? You know the formula, 1 upon RP is equal to 1 upon R1 plus 1 upon R2, because in parallel combination reciprocal of resistances get added. 1 upon R1 plus 1 upon R2 is equal to 1 upon RP. So how you write for RP? 1 upon RP is equal to R1 plus R2 upon R1 into R2. So how you write RP? RP is equal to R1 into R2 upon R1 plus R2. Okay? R1 into R2 upon R1 plus R2. Now here we similarly we write for V is equal to I1 R1. Therefore we write similar V for, and another V also we write I2 R2. Okay. Therefore we write here for I1 what you write, I1 is equal to V upon R1, and here yes, here I2 is equal to V upon R2. Right? Means this V you may write that I RP is equal to I1 R1 is equal to I2 R2. Right? This is also V, this is also V, this is also V. So I write I RP is equal to I1 R1 is equal to I2 R2. Now we know that I is equal to I1 plus I2. Okay, so here I write I RP is equal to I1, not necessary. I1 R1 I RP See, V is equal to I into RP. According to that, we derive for I is equal to V upon RP. Like that, we write for I1 is equal to V upon R1 and I2 is equal to V upon R2. These are your three equations. Now, dividing equation 1 by 2. Well, if LHS is I upon I1. What is RHS? V upon RP, V upon R1. By making reciprocal V cancel, we get R1 upon RP. So we get up to I1 upon I. हे सगळं तुम्हाला करण्याची गरज नाहीये किंवा हे एक्झामला येणार पण नाही. फॉर युअर अंडरस्टँडिंग हे डायरेक्टली कुठून आलं, व्हॉट इज करंट डिव्हिजन फॉर्म्युला कुठून आला हे समजण्यासाठी मी त्याच्या मॅथमॅटिकली प्रूव्ह करून देते आहे तुम्हाला. ओके, सो now what is the value of RP? Insert the value. Before that you want to get I1, so I1 is equal to RP upon R1 multiplied by R. What is the value of RP? RP ची value काय? R1 into R2 upon R1 plus R2 multiplied by 1 upon R1 multiplied by I. So R1 cancel. So how you get I1? I1 is equal to R2 upon R1 plus R2 into I. This is the formula for I1. Do you understand? Here, I1 we get RP upon R1 into I. RP upon R1 into I. We get the insert the value of RP as R1 into R2 upon R1 plus R2. R1 into R2 upon R1 plus R2. So R1 cancel. It becomes I1 is equal to R2 upon R1 plus R2 into R. Mathematically पण मिळालं बघा आपल्याला. Because we know I is equal to I1 plus I2, we know V is equal to IR. Overall resistance of the effective resistance of the parallel combination is RP. So overall V is equal to I into RP. But V is same here also. So we may write V is equal to I1 R1, V is equal to I2 R2. According to that, we get the formula for I1, we get formula for R2. And dividing equation, these two equations, dividing here you have to write. Dividing equation 1 by 2. तसंच dividing equation 1 by 3 जर केला तर आपल्याला काय मिळेल? I2 पण मिळेल. कसा मिळेल बघा? I upon I2 is equal to I काय होता V upon RP upon I2 काय V upon R2. V upon R2 V cancel होऊन जाणार. So I upon I2 we get R2 upon RP. Therefore I2 equal to RP upon R2 multiplied by I. By cross multiplication we get for I2. Okay. So from that we get I2 equal to RP काय मिळणार? आता RP चा फॉर्म्युला माहितीच आहे आपल्याला. R1 into R2 upon R1 plus R2, and what is your R2? Denominator multiply by 1 upon R2 multiply by R. So R2 cancel. So I2 is equal to R1 upon R1 plus R2 into R. Is it this way? Whenever two resistances are in parallel, I1 कसा कॅल्क्युलेट करणार फॉर्म्युला फिगरवरचा फॉर्म्युला लक्षात ठेवा I1 इक्वल टू R2 अपॉन R1 प्लस R2 into R and I2 equal to R1 upon R1 plus R2 into I. Do you understand, all of you? Now we are going to simplify one numerical. Before that you complete this, or if you have any question, please ask. Please tell whether you understand or not. I1 आणि I2 चे डेरिव्हेशन तुम्हाला पाठ करायचे नाहीये फॉर युअर अंडरस्टँडिंग. तुम्हाला समजायला पाहिजे I1 आणि I2 नी करंट डिव्हिजनचा फॉर्म्युला हा आहे असं सांगून पण पुढे गेली असती, पण I1 आणि I2 कुठून आले ते तुमच्या प्रिव्हियस नॉलेज पासूनच मिळवले, बट दे आर द स्टँडर्ड फॉर्म्युलाज नाउ. प्रत्येक वेळी I1 आणि I2 ची व्हॅल्यू डायरेक्टली तुम्ही अशी यूज करू शकता. ओके. Now one very important thing is that one important thing, what happens whenever three resistances are in parallel? That is very important. Suppose third resistance is R3. Here your R3. At that time I1, I2 and I3. And what you write? I is equal to I1 plus I2 plus I3. Whenever three resistances are in parallel. Whenever three resistances are in parallel, what do you have to do? You have to find out the values of I1, I2 and I3. That is quite different now. Now you are confused about R2 and R3, which resistance is at the denominator. So, suppose you want to calculate I1, then you have to find out the RP23. RP23 means parallel combination of second and third resistance. That is at the numerator. So, how do you calculate? I1 is equal to RP23 upon R1 plus RP23. Means this diagram you have to convert like this. Here your R1 and here these two resistances parallel combination. Means two resistances you have to convert this diagram. Here your R1, okay, and here this RP23. Means parallel combination of R2 and R3. So, how you write I1? I1 is equal to this RP23 upon R1 plus RP23 multiplied by R. Okay, so your I1 is equal to RP23. How you calculate parallel combination of 2 and 3? Means here R2 into R3 upon R2 plus R3. Whenever two resistances are in parallel, their formula is their multiplication of the two resistances at numerator and addition at the denominator. So whenever R2 and R3 are in parallel, then R2 into R3 upon R2 plus R3. So that is termed as RP23 upon R1 plus RP23 into R. Okay, so how you write I2 now? How you write I2? I2 कसा काढणार आता? I1 here, R2 as it is. Here R2, here R1 and R3. Means here RP13. I2 जर काढायचा असेल तर काय आहे? While calculating I2, remaining two resistances are in parallel and that parallel combination is at the denominator. So equal to RP13 upon R2 plus RP13 multiplied by R. Okay, and to calculate I3, tell me what is the formula for I3? I am waiting for you. Anyone give the answer? What is the formula for current division in third resistance? I3. Sakal. Anyone? I am waiting for Mayank, Rohan, Anushka, Umang. Anyone? No. I3 काढायचं आहे ना? मग उरलेल्या दोघांचं पॅरलल कॉम्बिनेशन न्यूमरेटरला येईल ना मयांक? Mayank, do you understand? We want to calculate the current through R3. That's why remaining two resistances are R1 and R2. Yes. Right, Rohan, Anushka, Mayank, do you understand? Means from this resistance R3, what is the current that you want to calculate? Then you consider the parallel combination of remaining these two, RP12 upon R3 plus RP12 into R. So here the formula is RP12 upon R3 plus RP12 into R. आता थोडं डोक्याला त्रास द्यावा लागेल. सगळ्याच गोष्टी एवढ्या स्ट्रेट फॉरवर्ड सोपं नसणार आहे, पण नॉट सो कॉम्प्लिकेटेड. वन बाय वन अंडरस्टँड केलं तर सोपंच आहे. टू रेजिस्टन्सेसचं पॅरलल कॉम्बिनेशनचं आधी शिकवलं मी तुम्हाला म्हणून. आता तीनचं पण आपल्याला यायला पाहिजे. ट्रिक काय आहे आपल्याकडे? ज्यातनं करंट जायचा काढायचा आहे तर उरलेल्या दोघं रेजिस्टन्सचं पॅरलल कॉम्बिनेशन न्यूमरेटरला येणार आणि डिनॉमिनेटरला तो रेजिस्टन्स स्वतः प्लस दोघांचं पॅरलल कॉम्बिनेशन and multiply by I as it is. Okay, do you understand, Maya? Now do you understand? So write down these three formulas. These are very important. And now we try to simplify one numerical like this with mathematical values. यातलं काय तुम्हाला अंडरस्टँडिंग साठी काढून ठेवायच्या डायग्राम काढले तरी चालेल. Okay, Maya, Rohan, Anushka, all of you understand and right answer. Very good. All of you tried. That is very good for me. Maya, don't bother. चुकलं तरी चालेल. आन्सर दिलं हे माझ्यासाठी खूप आहे. सगळ्यांचंच राईटच यायला पाहिजे, नॉट नेसेसरी. काहीतरी चुकलंय म्हणजेच मग तुमची कन्सेप्ट आता परत एकदा मी एक्सप्लेन केलं ना म्हणून. डू यू अंडरस्टँड नाउ ऑल ऑफ यू? Now again we try to simplify one exercise numerical. पूर्ण बोर्ड क्लियर करते मी. Now this one is very important numerical. If you understand this numerical now, exercise numerical, you never forgot or you never forget about current division. कधीच नाही विसरणार तुम्ही. So write down exercise page number 37. आता सगळं बोर्ड युटिलाइज करते मी. Page 37 exercise unsolved आहे हे परत तुम्हाला कुठेच नाही मिळणार. So write down the solution हे मी तुम्हाला एक्सप्लेन करून देते, सॉल्व करून देते. Write down in proper order. Exercise 6. Write down the numerical. One diagram is there. First we draw that diagram. They asked to find equivalent resistance. Write down after drawing the diagram. Write down find equivalent resistance of the network. R equivalent resistance of the network. Second thing they asked to calculate value of current supplied by a battery. Means they asked to calculate total current R. And also they asked to calculate value of branch currents. Value of branch currents. I1 is equal to what? I2 is equal to what? And I3 is equal to. Okay. Now first answer we start now. Simplifying. For that write given V is equal to 6 volt. Then Ri internal resistance is given 0.2 ohm. Then R1 is equal to 2 ohm. R2 is equal to 3 ohm. And R3 is equal to 6 ohm. Okay. Okay. Now first we try to find out the equivalent resistance. Equivalent resistance, so make that figure like this. ह्या figure ला असं उभं करा. This R1, R2, R3. So you have to calculate RP1, 2, 3. RP1, 2, 3 means 1 upon RP1, 2, 3 equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So 1 upon RP1, 2, 3 cross multiplication करत बसण्यापेक्षा insert the values 1 upon 2 plus 1 upon 3 plus 1 upon 6. So it is LCM 6. So 1 upon RP1, 2, 3 is equal to 1 upon 1. So the value of RP1, 2, 3 is equal to 1 ohm. So our diagram is like this now. Here R and here RP1, 2, 3. With this diagram we convert this parallel combination. All these three parallel combination like this, and here your RR. So what is the equivalent resistance? Therefore, R equivalent is equal to Ri plus RP1, 2, 3 Why? Because these two RR and RP123 are in series. We calculate RP123 and RI is given. So 1 plus 0.2. So resistance of this circuit, this overall circuitचा पूर्ण resistance ची value काय येणार? 0.2 plus 1. Therefore R equivalent is equal to 1.2 ohm. R equivalent is equal to 1.2 ohm. Do you understand? If any question, please ask. फक्त याला मी काय केलं? रिड्यूस केलं. या तिघांचं पॅरलल कॉम्बिनेशनचा रेझिस्टन्स या दोन पॉइंटच्या अक्रॉस असेल. हे जर मर्ज केले तर Rp123 कसा काढणार? We know when resistances are in parallel, their reciprocals get added. So Rp123 is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So we get 1 plus Rp123 is equal to like this. Mathematically we easily simplify and then we write here between those 2 points 3 combinations, 3 resistances parallel combination is there. Therefore 0.2 plus 1, 1.2 is R equivalent. So we simplify first one, we find out R equivalent. Okay, all of you understand this? Okay. Now we try to find out R. Overall R. I is the current due to the 6-volt battery. Therefore V is equal to I into R equivalent. We know V is equal to 6. I we want to calculate R equivalent is 1.2. R equivalent just we calculate 1.2. Therefore, our overall current of the circuit, overall current is equal to 6 upon 1.2 is equal to 5, right? 5 ampere. Therefore, second also we calculate I is equal to 5 ampere. Okay. So write down this one. Any doubt about this? Overall circuit potential V is there. So V is the potential drop across R1, V is the potential drop across R2, V is the potential drop across R3. So V1 plus V2 is this one. So according to that we find out the equivalent resistance. Therefore V is equal to I into R equivalent. So 6 is equal to I into 1.2. Like this we calculate. Okay, now we try to calculate I1, I2, I3. For that, we have to use the formula for current division. According to current division, now concentrate on this. I1 to calculate I1. What is the formula? Rp23. I1 मध्ये जाणारा current असेल Rp23 at the numerator and at the denominator there is R1 plus Rp23 multiplied by Ri. Okay, to calculate I1, Rp23 upon R1 plus Rp23 multiplied by R. So how you write Rp23? Rp23 means R2 into R3 upon R2 plus R3 upon R1 plus R2 into R3 upon R2 plus R3 multiplied by R. The value of parallel combination of R2 and R3. How you calculate the parallel combination of R2 and R3? R2 into R3 upon R2 plus R3. So same value we place here and our formula as it is. R1 as it is, I as it is. Now we know all the values of R1, R2, R3 and I also. Now putting these values, calculate I1, value of I1. So what is your R2? R2 is 3 ohm and R3 is 6 ohm. So 2 into 6 upon 2 plus 6 multiply R1 is what? 2 plus 2 into 6 upon 2 plus 6 multiply by 5 ampere because I just will calculate 5 ampere. So what is the value? 12 upon 8. See, this 12 upon 8, 1.5. This bracket is equal to 1.5. So 1.5 upon 2 plus 1.5 multiplied by 5, which is equal to this one is the value of R1. R2 is 3. R2. Sorry. 306. Sorry. 3 into 6 and here 3 plus 6. 18 upon 9, which is equal to 2. Therefore, what we get? 2 upon 2 plus 2 multiplied by 5. 10 upon 4. 2.5 ampere. Therefore, I1 is equal to 2 upon 5 ampere. This means out of this 5 ampere, 2.5 goes through this branch. Of course, या branch मध्ये जाणारा करंट अजून कमी असणार आहे. 5 एम्पियर मधला 2.5 इकडे जाणार आहे कारण हा कमी व्हॅल्यूचा रेझिस्टन्स आहे. इथे जास्ती अपोजिशन आहे त्याच्यापेक्षा इथे खूप जास्ती अपोजिशन आहे. म्हणजे I3 ची व्हॅल्यू सगळ्यात कमी येईल. त्याच्यापेक्षा थोडी जास्त I2 ची आणि त्याच्यापेक्षा जास्ती I1 ची. Whenever opposition is more, current through them is less. Now you calculate I2. Anushka, Rohan, Mayank, all of you try, and remaining students are also try to calculate I2. Now for I2 you have to write Rp13 upon R2 plus Rp13 multiplied by R. So we calculate Rp13 first, that is R1 into R3 upon R1 plus R3, which is equal to 1 is what 2. 2 into 6 upon 2 plus 6. Here it is. .5. So I2 equal to 1.5 upon 2 plus 1.5 multiplied by 5. 7.5 upon 3.5. Just do this up. 2.142. So our I2 is equal to 2.142. Anyone get proper answer? This is unsolved. 1.66 यायला पाहिजे. 1 and 3 ना 2 and 6. R2 is what 3. Anyone? Right, 1.66. Mayank, 1.66 is right answer. See here, I2 is equal to, here this one is 1.5. Huh? So 1.5 upon R2 is what? 3 plus 1.5 multiplied by 5. 7.5 upon 4.5, which is equal to 1.66. 75 upon 45, 1.66. Therefore, your I2 is equal to 1.66 ampere, and your I1 is this one. So, how you calculate I3? Anyone get right answer? Mayank, do you understand now? So, how you calculate remaining R3? I3 is equal to simple. One trick is there. Simply you calculate I3 because I is equal to I1 plus I2 plus I3. You know I, you know I1, you know I2, then calculate I3 easily. 5 equal to 2.5 plus 1.66 plus I3. Therefore, 6. 4.16. 5 minus 4.16 is equal to I3. Therefore, I3 is equal to 5 minus 4.16. 0.84 ampere. In this way, you calculate I3. Yes, I3 is 0.8, right? Now, do you understand how I explain this? I2 and I3, I is equal to I1 plus I2 plus I3. By using this formula, calculate I3. असाही काढू शकता किंवा what is the formula according to this current division? I3 is equal to Rp12 upon R3 plus Rp12 multiplied by R. This is also the formula for calculating I3. याच्याने पण calculate करून बघा, similar answer will be there. 0.84 or 8.32. Okay. परत एकदा recorded lecture बघा. For this or you may calculate like this. Okay, very good. Answer same as येणार. Okay, नाही. We'll continue in tomorrow's lecture. Next, पुढचं बघूया आता. किंवा करंट डिव्हिजनचा अजून एक न्यूमेरिकल सॉल्व करूया if you want. But read carefully and try to simplify this numerical in proper manner because that one is an exercise numerical. Okay? Bye.